Hello everyone, and welcome to the third webinar of Agile Data and Information Management, a short course presented by IT Masters on behalf of Charles Sturt University. My name is Guy Coward, and I'm your MC. Your mentor, as you might know by now, and I hope you do, is the wonderful Brenton Birchmore. Before we begin, just the usual housekeeping. We encourage questions and the use of chat during our webinars. You can send your course content related questions to the Q&A section, and you can send all your other, administration type and resource availability questions to Hannah in chat, and we'll try and get to both. You can chat with panelists as the webinar is going on, or to your fellow students as well, and you can make that choice by toggling through the drop-down box once you've opened the chat log. I really recommend all panelists and attendees, so everyone's kept in the loop and everyone gets all the funnies. And there's usually very experienced industry folk who can be helpful with anyone who needs a catch up. I'll interrupt Brenton if there's any particularly relevant questions, and we'll have a long Q&A session at the end, no doubt. And we'll try and keep it a bit shorter tonight. We've been going long. We'll see how we go. Hannah is here, so thank you, Hannah, in the usual role, keeping the cats herded. Also responsible for the course page, learn.itmasters.edu.au, and you can find all the course materials you need. Brenton's wonderful audio recordings, discussion forums, quizzes, exam, which we'll talk about next week. So if you have any questions, let Hannah know. I think that's enough for me. How's your week been, Brenton? What's been going on?
My week has been pretty simple, pretty ordinary. We don't have any big things happening at all around here at this point. We had a fantastic thunderstorm last night, right during the middle of a webinar that I had on one of my topics, one of my subjects. So it was so loud it startled me in my chair a little bit. And yes, it did come through the microphone. We don't have one today, unfortunately. So anyone's looking forward to a bit of thunder and lightning.
Well,
we missed it.
More than the usual thunder and lightning that is your wit and joie de vivre, I don't know.
Well, I'll try and get it a little bit smoother than thunder and lightning, but
I call my left vocal cord thunder and my right vocal cord lightning. My name is Brenton Birchmore, and I'm talking data visualization. Also, where's the video? Come on, don't hide.
Here I am. Hey, folks.
And it's a beautiful haircut.
It's a recent haircut, definitely. And hello, everyone, for joining in, and hello to everyone who's calling out. The names are whizzing by far too quickly for me to call back to each of you. But thank you for saying hello and g'day. Are we ready to begin, Guy? Should we kick off? What do you think?
Yeah, let's do it.
Let's get it. We have a quorum.
Mm-hmm.
All right. We have been on a bit of a journey. We have been putting together pieces of the puzzle, and this week is going to be one more of those pieces. We will, as usual, try and tie all of these things that we're going to cover tonight back into information and data management. And we're going to talk a bit about some of the traps and pitfalls, some of the things that aren't necessarily obvious that we might need to think about when we're tackling the question of data visualization. I want to talk about data visualization from the point of view of the decision making, as that's what its goal is. Next week, our final week in topic 4, we'll be talking about these more from the IT perspective. So that's going to talk more about the creation of the tools and systems that are needed to make all of this possible. All the things we've talked about in weeks 1, 2, and now 3. We'll be talking next week about what goes on behind the scenes, under the hood, in the engine room of IT, and how that relates to the management of information and data, because that's where a lot of the important stuff happens so that it can be used. But what we're talking about tonight is how we're going to use the data that we have access to. So we are kind of making the assumption that we've got it, and now we're going to use it a little bit. So a reminder of the syllabus of what we've been talking about. We talked about decision psychology in week 1, where we touched on a little bit about how the mind works in making decisions. We then spoke a little bit more about the principles of Agile broadly, and how that impacts decision making, and how that impacts the availability and use and function of data and information. Tonight, we're going to talk about data visualization, and next week, we'll be covering the way in which all this can come together in the modern dashboard. So here's where we're at. This is what we're up to. What we're going to cover tonight is we're going to talk a little bit about the visual part of visualization. We're going to talk a little bit about how the brain sees things, how it can trick us a little bit, some of what current research is telling us about how we get a little bit distorted in what we're looking at and where that comes from, so that we can be better prepared, not only within ourselves, but for others, in how to deal with that, where we start to put data into visualization tools. There are a number of data visualization frameworks, typologies, etc. out there. I have picked a couple, and I'm going to share those with you as examples of how this whole process can be broken down and put into a framework that might help us make some decisions about how we visualize our data. These are not the best, the only. There are a number of them out there, but these are relatively recent and relatively robust. And so this is just a place for you to start. We are going to talk about some ideas from business, from practical design of visualizations, a bit of a guidepost on where to go. It's a little bit more generic and high level, whereas the framework is a little bit specific. The practical design elements are a little bit more broad. And that's also taken from an example that has been published in the Harvard Business Review. So we're going to be, if you want to get more details on any of these as we go through, you're welcome to obviously grab the links which are up in the portal. And of course, along the way, we're going to keep talking to how this relates to the information, its management, its gathering, its handling. Now, I am aware that we've gone on fairly lengthily. Well, is that a word? I'm not sure it is now. And we have extended our Q&A, which we can do again tonight, but I wanted to maybe try and be a little bit more concise with some of the initial comments that we're going through and leave you guys a little bit more time for Q&A and wrap things up a little bit at the end. Now, for those of you who aren't quite ready, who haven't had enough either chocolate or alcohol to be ready for the heavy science, I apologize, because we are going to use a little bit of psychology right up front. Don't be too concerned about the buzzwords. They're just buzzwords. But we're talking about consciousness, dissociation framework. What we're essentially saying is that we don't actually see what we see. So we know already that the mind processes what we see. Our eyes see things. There's a physics element, photons, retinas, we know that part. But it all gets interpreted by the brain, which is essentially the software. And we know that there's a great deal of interpretation. But we also have learned that some of that interpretation happens before we even decide what we see, which is a little bit scary, a little bit freaky, and a little bit challenging when it comes to visualization tools. So some fundamental points. Our brain interprets what we see. We know that. That's always the case. We like to think we interpret accurately, and for a lot of simple things we do. But the more complexity in what we're trying to see and understand what we see, the more we're at risk of some sort of dissociation happening. So the interpretation is always subjective, and there are a couple of key mental processes or forces that are at work that are highly relevant to the way in which we process visualization. And we're going to touch on those in a moment. But these come from our subconscious. So if you think of our conscious mind, we look at something, we think we know what it is, we pay attention to it, and therefore our logic mind tries to analyze it. But our subconscious mind has already quite sneakily done a bit of that for us and is influencing our attention, our conscious mind. It's influencing our logic and altering to some small extent, or in some cases and in some people, perhaps a larger extent, altering what we think we see. This phenomenon is known as pre-attentive processing. Pre-attentive processing is the buzzword for what happens when our brain looks and processes things subconsciously before we consciously focus on it. One of the interesting things, and this will be no surprise to anyone, that our goals, our wishes, our intentions, or our expectations, which are living in our subconscious, that gets a chance to influence what we see before our conscious mind says, okay, what am I looking at? Right? So for all those occasions where you've either been the person or you've witnessed someone who's looked at something and you know that they have an agenda, you know that they have an axe to grind, they have a particular play that they want this data to do and say something. They want this visualization to mean something in particular. And that's what they see, even when that's not what's there. Now, that's an extreme example because there's lots of subtlety in between. That's what this leads to. Now, let's put aside the fact that some people will actually see what's really there and pretend they don't because they just want to argue about it. That's a separate issue. This is talking about people who actually believe they see what they interpret. So let's dig a little bit deeper on what pre-attentive processing is and where it comes from, because this is going to be something that we'll come up against when we're using data visualization in order to influence a decision. Two kinds. The first is the simplest, and this is called pure capture pre-attentive processing. What this is things that just stand out. Things that are more obvious in some way are going to be processed more quickly. Not only are they going to be processed more quickly by the mind, you can imagine that, right? Something a little bit bigger, we might more quickly decide what that is. There's more to it. We prioritize its importance. So think about that for a second. Something that is more quickly recognized by us is more important to us than something that takes a little longer to understand. Now, factor that in to the intention behind the whole purpose of visualization tools, and that is to make decisions. What does that do to our decision making? So when we talk about stimuli that stand out with things that are bigger, things that are bolder, things that are bigger, stronger colors, all the things that advertising has been doing to us, website design is full of these phenomena. The whole idea of white space in visual design to allow something to stand out separate from everything else, those are methods that tap into pure capture pre-attentive processing. It's a way of saying, well, this is easy to figure out, so you're going to spend a little bit more time thinking about that. And even later, when you're adding it all up, that's going to have a little bit more weight behind it. And of course, in the case of a website, they're obviously hoping you click on it, for example. So that's pure differential in how easy it is to process. Right? Salience. Contingent capture, that's the other thing. That's the thing I just mentioned before. That's the stuff that's perhaps a little more difficult to deal with, because that's the stuff that comes from what's already in the viewer's head. That's the stuff that's their goals, their intention, their wishes, their dreams, their hopes, their fears, whatever it is that's in their mind. Now I want to step back and forgive people for this a little bit, because underneath that is another layer that says that what it's really all about is familiarity. So what we are more familiar with will get processed more quickly, will get understood more quickly, and will have a higher priority. The reason that's important here is because what we are all more familiar with is what we want the graph to say, what we want the insight, what we want the meaning to be, because we've already thought about it. We've already imagined it. And that simple fact means that it's more familiar to us. And when we recognize what we think is that recognition, subconsciously triggered, is going to influence how we evaluate and consider and judge that little piece of information in the visualization. This is normal human nature. This is just the way our brains work. And so there's not much point in us saying, come on, everyone, look, just be neutral when you look at this graph. Don't bring your agenda with you. Just look at it. Like, they can't. We can't. We will do the same thing. Yes, we can limit the impact. We can consciously try to put those things aside, but we're still fighting something that's real. So this is a real challenge when we want to have a shared understanding. And let's go back to the point of when we're trying to use data visualization in order to influence a decision. Like here's a chart, here's a graph, here's a table, here's something. Let's all talk about this as stakeholders, and let's all have a shared understanding of what it says and what it means and what insights it reveals. And then we can make a decision about that. That's the sequence we're looking for. Shared understanding has some real challenges that any data visualization needs to be able to address. So the first is that it's not spontaneous. It's not automatic. It doesn't just happen. We don't just get several people in a room looking at a graph and say, well, we all understand that the same way. No, doesn't happen. It does not happen of its own. It should never be assumed to happen. That's the fallacy of assuming a shared understanding, that we assume we don't have to do any work. The graph will do the work for us. Absolutely it won't. It'll do some, but it could do more harm than good. It could allow a person to go into a different understanding that's remarkably different. So it's a process. Even when you have a data visualization that looks awesome and you spent hours on it, that does a fantastic representation of exactly what you think it should represent, and someone else who reads it, or three people that read it, get four different ideas because someone changed their mind halfway through. So it is a process. And this is where data visualization, using it to create an understanding in an audience, is not about saying, bang, here's my chart. Isn't it beautiful? Look at all the stuff in it. It's something that we do gradually. It's a constructive process. Remember, we are looking to alter what that person understands. We would use the same constructive processes that we would use to educate them on anything. We build piece by piece. So when we build our visualizations, if we can build them in layers, if we can build them in stages, or have several of them that follow a sequence, maturing the insight and the message and the complexity over time, we will have a much stronger shared understanding amongst our audience. Build from the most obvious, the easiest to understand, the most familiar. Get past that pre-attentive processing stage, but without giving them a large amount of distractions and other things that will allow them or make it easier for them to mentally go off on a tangent. Start small, start simple, start with something that's a lot less arguable so that they can then work from there. Even when you get that, even when you have a baseline of shared understanding, it's still a fragile thing. It's subjective. And when people are, they've left the room and the issue is no longer being discussed, it's not top of mind, then there is always the chance that their thoughts about it will devolve back to the familiar to them, whatever that is. So just because we got a clear understanding last week, when we come back next week to have another chat about that graph and that table and that chart, it doesn't mean that that shared understanding is just as robust now as what it was a week ago. We might need to check for that. But we absolutely need it, because we are talking about data visualization as a piece of the puzzle in making the best decisions we can make in our organization, in our agile organization. So this is just a tool. This is just a step in the process. And so we need not just to have the great data. We need not just to have the good decision-making processes and timing. We need to not just have great visualization. We need to have the shared understanding of what that means. So let's get a little bit practical, and let's talk about some of the visualization components that are easy to see, because we want things to be easy to see. Size is a big element. The relative sizes of length is easier to measure by the human eye than area. So this is why this is why a pie chart is not as easy to compare the sizes of to a line chart. You can see more easily the difference between the height of various lines, then, or a bar graph, the different bars, how high they are, much more easily than you can see the relative difference between slices of a pie. Doesn't mean pie graphs aren't great. It just means that if the size is really what you need, then length is easier than area. Obviously, the pie chart is great for having proportions. Position. The relative location of something within an area is something that the eye can see relatively easily. We can see that something's on the left, and we can see that something's on the right. Up, down, yes, we can do that as well. So left, right, top, bottom, that's pretty straightforward. That's the cardinal points of the compass. Once we go beyond that, it starts to get a little bit more hazy and a little bit more complicated. Spatial recognition, spatial recognition is one of our great strengths. It has been since our earliest evolution of humanity. Color. Now, green is one of the easiest colors to recognize because of its wavelength. And I think from memory, it's like 555 hertz or something, in the middle of the spectrum that makes it relatively easy compared to other colors. Blue is a little harder than some other colors. Warmer colors are typically easier for us to spot than cooler ones. Now that's circumstantial because some situations, some lighting, some background will sometimes alter that. Contrast will alter that. But color, you can see, obviously the red one has popped out. Shape, this starts to get harder and harder to differentiate. We can differentiate geometric shapes, and density is another thing that we can get. But these get less precise. It's harder for us to judge shape. We can judge the angle of straight lines more easily than we can judge the angle of curves. So geometric shapes that have hard lines and straight lines and solid angles are easier than geometric shapes with curves in them, unless it's a pure circle. But it's easier to judge the size of the different sizes in two squares than it is to judge the difference in size between two circles. Again, because length is easier and we're measuring the length of something across a particular axis. So when we're looking for things to pop out, when we're looking for differentiators, things that we want to be pure capture, easy to process, the things you want to look for is size, position, color, and then maybe something else if you need it. So let's have a look at a visualization framework. So this is an example framework that I mentioned, and it is linked in the portal, and I put a couple of slides in. I'll put the source of where this is from. It's from a research white paper that is from the proceedings of the National Academy of Sciences in the US. Now, it starts with a premise, and this premise is independent of the framework. This is the reason we need a framework, or why a framework is beneficial. When you're looking to say, okay, well, how are we going to visualize this? What sort of visualization are we going to do? There's a bunch of things that are going to be factors that play into this, and we need to consider all of these. We don't just want to grab the easiest thing or the first thing we think of. We want to consider the nature of what information we're looking for. What insight are we after? What's our query? What's the need here that the visualization is hopefully going to fulfill? Another thing we look at is, well, what can our data do? What kind of data do we have? And in a moment, we'll look at different scales of data that spell out how you would look at what the data can do. But how strong that data is a relevant question. The method of analysis, and that's obviously going to be dependent upon the nature of the data, but also it's going to be dependent upon the query that we're asking. If you want to be looking for a trend, then the nature of your analysis is going to be periodical. It's going to have chronological data in it, for example. The type of visualization tool, and then the stages of exposure of the data flows. Remember, we talked before about the benefits of the gradual exposure to an audience of pieces of information. So how do you categorize those stages of understanding? Not necessarily stages of or categorizations of data. It might be the same, but it might not. Now I'm doing that to you right now. Look at the difference, right? Look at the difference of what I did here. There's 5 bullet points that have arrived to you all at once. Think about what your mind did at that point. And then think about what this does for you as we go through point by point. It's a very simple example of exactly that concept in motion. Let's look at the types of needs. And this is just an example list. There are a number of different example lists out there. Different researchers have come up with different categorizations or different types of needs and questions. You will have your own list as long as you have an understanding that the need is not always the same. And that's going to be a big factor on what kind of visualization is required. So sometimes you have a very simple categorization. You're just clustering things where you just wanting to identify the type. It could be that you need to order it, rank it, sort it. You do need to differentiate, but in fairly broad terms. You just need to know which is better, which is not. You're not measuring the distance between them at this point. A is better than B, but by how much? Doesn't matter yet. But in the next stage, the differences do matter. So they have to be measurable. So if you need to know the distribution of things, you need to know how far, what's an outlier? Well, an outlier is something that is a certain distance from the mean or the median. You need to know enough information to see, well, that's far enough out. We can measure that distance. Comparison is a ratio scale that you need to be able to have multiple measurable attributes. You could just compare one, but if you're just comparing one, then you just have a rank distribution. Trends, with a trend query, you're going to need a time axis in that data field somewhere. So we're going to need some sort of chronological component in our data points that allow us to map out relational differences measured by time. And perhaps geospatial, you might be looking at the interconnectedness and the relationship between things. So geospatial would be, this is over here and it's connected to this over here, and this is connected to this, but it's not connected to this. So you see things like org charts are a good example, a simple example of showing interconnectedness and relationship attributes. So knowing what the need is, knowing what the type of query, the type of insight that we're looking for is one of our starting points. But the data itself is another. And the data is simplified, and this is a gradient scale. So the data gets stronger as we go through this list. Nominal data has no real values to it. It has some labels, and it's good for categorization, but that's kind of about it. And an example of nominal data would be roles in an organization. So, you know, the salesperson, the this person, the admin, the technician, the this, the that. So you don't have enough data to rank them or sort them or do anything. You can merely categorize them. Ordinal data has some qualitative assessment, but not quantitative assessment. So we might be able to sort them, but we can't compare them to each other. And an example would be chapters in a book. We know that chapter 1 becomes before chapter 2, but we don't know which chapter is better. We don't know how long each chapter is. We don't have that level of detail yet with ordinal data, but we know what order they will go in. Interval data is data that has a distance that's measured in between its data points. So the distance between, the interval between is measurable, but absolute zero is not fixed. So we don't have a way of always anchoring zero at the same point. So you can't easily compare one to another. You can compare different points on a scale, but you can't compare two different scales because they don't have the same 0 point. 0 is arbitrary, and temperature scales is a great difference, right? You've got Celsius or centigrade, you've got Fahrenheit, and you've got Kelvin, and 0 is in 3 different places in actual temperature. Then you have ratio data, and this is where you have lots of specific values with a non-arbitrary 0. 0 is 0. It's the same each time with each data cluster that you use. And examples, things that we're used to, simple measurements of length, size, weight, or in more commonly in business, dollars. Right? So how much data we have is going to determine what we could do with it and what kind of queries we can answer with it. Now, this is a snapshot of how the framework then starts to put different types of analysis and different types of visualization. This is only a portion of it. And won't go through this in too much detail because it starts to get quite detailed. The link is in the forum, and here it is here. So this is just an example. So you might have a different one, you might have a favorite. If anyone does have other examples of these things that they like, put it in the forums after the webinar, and share it with everyone and show what you've got, because that's going to be something that someone else might find useful and valuable. Let's have a poll. Can we do a poll, Guy? Have we got one ready?
Oh, yes. Let me just queue it up.
And should we do some questions while we do the? No, let's do the poll first. Give people a chance to think about the poll.
Yeah, rightio. A couple of quick questions then. Brendan asks, are infographics considered data visualizations?
Yes.
Thank you.
Because data visualization, one of the most powerful blends is text and data. So text and numbers. So in fact, some studies have said that you can significantly increase the speed of comprehension of visualization when you add labeling text in appropriate places, and that helps contextualize what you're looking at. It'll speed up the understanding of it. And infographics are a more abstract version of that principle, but that's exactly what they are. And you'll find that good infographics will use size and position and scale. They will position to create they'll put them in the right order to create a scaffolding of understanding. So the infographics data that it gives you first will be a foundation understanding to what you see further down, for example. Also, you'll find that the amount of area that's attributed to a particular data point, might be specifically chosen because of the number, because of the scale, because of its importance, etc. So it, yes, follows all the same sort of rules.
Thank you. And just a quick one on color. How do we tackle an audience who might be colorblind, and how does that affect the need requirements?
It certainly does. And you need to use, in that case, you would need to use pattern. So a lot of visualization tools that not only have color, but they have pattern-based fill. So you could fill with a color, or you could fill with pattern and use pattern differentiation. So for people who have color vision, the pattern is not going to be as powerful for them, because their brain is easier to recognize colors. But for people who are colorblind, don't have that option, you'll find that in a lot of cases, their brain is actually better at spotting pattern differences. But I wouldn't just use hue, tone, or density, because whilst that's discernible, that's not as strong as using a pattern.
In your experience, do some of the platforms that we're going to be talking about have accessibility options? Like people can, say they've got a profile, they can actually say, I'm colorblind, therefore can you represent the data differently for me?
Yeah, yes. Many of the modern products, and we don't really have a product review component with what we're discussing, but there are some links that we've got up there that point to some of that. And yes, the better ones today, absolutely, they have accessibility options that allow you to use pattern fill, but it's still up to the creator, right? If you're the creator and you're using the visualization software, that's just a tool in order for you to create another tool, making the point that the visualization itself is just a tool for decision making. So when you're building the tool and you're using the software tool, you choose based on your audience. So the same points that I made earlier about choosing how you construct the exposure of the data, choosing how you make differences, knowing your audience and what they're familiar with and what they're looking for, or what their limitations and challenges might be, and having a shared understanding. Colorblindness is just one of them. And in some ways, treated no differently to any of the other limitations that everybody has in getting a shared understanding.
Beauty. Let's look at this poll. 83% of people have answered already. How much Is data visualization used for decision making in your organization? Rarely, sometimes, often, and regularly. Sometimes and often, both 31%.
See, I mentioned to you, Guy, that I deliberately did not put a fifth option in the middle because I wanted to make it harder for people to just sit in the middle and go, yeah, whatever, I'll just aim to sit on the fence, right? And our audience has still managed to find a way to sit in the middle by making points 2 and 3
Perhaps
the
this
same.
is a poor visualization, or a poor way of asking the question.
It would be harsh of me to imply that this data visualization is representative of the burning inherent need that we all have to simply sit on the fence and pick the middle option. That would be a harsh call. But if you and I had just had a lengthy debate about that very concept, then your pre-attentive processing would probably point that data to you and say, that's evidence.
Probably.
And that's how pre-attentive processing deceives us. But it's not. This is just honest answers from our audience.
I have huge access to grind. Don't
unless someone in the chat is about to own up to the fact that, yeah, I was looking for the middle, so I just went, up or down. I doubt that. But interesting that we have more people that use it regularly than people who use it rarely. And, that's a great sign. That's a sign of the times. We are moving in that direction. And if you take this poll again in a few years' time, it'll keep moving downwards, I suspect.
Thanks.
So there's that, and that is a question of, how much do people, I already shared that. You shared that. This is a question of how much you're doing now, not how much you want to do it, which is an entirely different question, which we didn't ask.
Nor will we.
So we've touched on a framework that at the very least tells you that there's a few things to figure out. We need to figure out a little bit about what we're trying to do, what we've got to work with, who we've got to work with. But that seems a little bit scientific. That seems a little bit granular. That seems a little bit, does that really work? How does that work in a typical organization? What else do we need to think about when it comes to tackling this from a purely everyday organizational perspective? I have another model to share with you that tackles it from a different angle. And for some of you, this will be an easier approach. It'll be less scientific. It will be the sort of thing that you might do if you are less familiar with or less frequently dealing with or building or creating visualizations. So this model begins with two key questions. It's a very simple model. It's just a two-way axis, up, sideways, up and down. This asks two different questions that we need to ask before we decide what to do with our visualization. Firstly, are we looking for something that's conceptual, or are we looking at something that's very explicit? So this is talking about the need. Are we needing to say something that's abstract and amorphous, or something that's really data-driven and specific? So that can also be phrased as, is it purely qualitative in nature, or do we have quantitative stuff to work with? Often that translates to your future stuff that doesn't exist yet. So it's inherently conceptual. And historical, well, it does exist, and assuming we know it, we've got it, then it's inherently explicit to some extent. The second question we're asking is, are we trying to be declarative or exploratory? So are we trying to say what it is or learn what it is? Are we trying to use our visualization to portray a statement of fact, or are we trying to use our visualization to reveal some insight that is currently not fully known to us? So are we looking to say, this is how it is, do we all agree? Is our shared understanding to say that we agree with this truth? Or are we using this visualization to create a shared understanding that we don't know what that is yet? So hypothetical or empirical? Empirical meaning, we discover. So here's the matrix. Here's our axes, right? So More explicit or data-driven is on the right here. More conceptual is the other end of that spectrum on the left. At the top is the declarative, and at the bottom is the exploratory. So this matrix is going to give us a rough guide as to what activities might fit into what category. So if you've got something that's highly declarative, you're declaring something that what is, but it's not full of explicit data, then you're illustrating an idea. And the article talks about this as consultant's corner. So this is where you say, here's my idea. The idea itself is clear. There's not a lot of ambiguity about it. We're not exploring this. We know it, but we're not expressing it in numerical terms. We're just expressing it in conceptual terms. It's using representative ideas. Down here, we have the stuff that is essentially what feeds into the creative process. So visualizations that are highly exploratory, full of unknowns, full of concepts, this is where you might be looking at vision planning. You don't necessarily have, this is what you'd use for determining strategy, exploring strategy, generating ideas. Across here, our visualizations are working with more explicit data. We have the numbers, but we don't have the answers. We know what's going on, but we don't yet fully know what it means to us. So we're using visualizations to discover things. We're using visualizations of actual data, historical, clear, uncontroversial data to say, what can we learn from that and how will that inform our decision making? And the last quadrant is the everyday reporting. This is the everyday stuff that says, oh, here's the report that says this is how much we sold last week. This is how much we processed. This is how much we did, or this is what happened. And this is not really reported and created as visualizations to tell us something. This is about mostly as a statement of fact that we're confirming that that is a true fact and that we're all in agreement with what that fact is and means. But it's not usually meant to be a mystery. So we're declaring it. Here's what happened last week. That's the reporting. This is where reporting, traditional reporting, and all of the visualizations that have come from that, that's where we've lived for decades. This is what gave rise to the spreadsheet. This is what gave rise to the table. This is what gave rise to bar graphs and line charts, right? Because you want the sales figures to be doing that, right? You want them to be going up and you want the incident reports to be going down. So that's the simple everyday reporting. We'll say, well, here's the fact. Now, a lot of that reporting gets used as food for other queries, needs, or requirements that might be say, well, these numbers are going in the wrong direction. The last 3 times we've had a explicit declared report of what happened, it's not going in the right direction. So now we need to go and look at another set of data. Perhaps our bar graph and our line chart is not enough to tell us why it's going in that direction. We need to do some different visualizations. Maybe we need to look at a number of reports over a period of time to see if there's a trend, for example. So this is an example model. As I said before, there are other examples. I'm using this to demonstrate the purpose, the benefit, the function of having a model, a framework, a typography that says we need some mental process to determine where do we start and where do we go when trying to decide what visualization is appropriate. Here's a breakdown of them in a little more detail. So idea illustration is the idea of we know something, we want to express it, we want to share it, and we don't have all the data. It's a concept. All right, so the infographics, some infographics fall into that category, or the infographics usually do work with clear data, but they're also usually aiming at something a little bit higher. Idea generation is the brainstorm food. It's the stuff that we are looking to visualize so that we can look for inspiration. We want creativity. We want innovation. So we don't want to be locked in with these visualizations. Some of the great visualizations that are good for this is things like heat maps. So a heat map or a word map, for example, will tell you how many times a particular word appears. What does that lead to? The data is trying to show that there's some hidden meaning here, there's some insight, but we need to decide what that is. We need to explore what it might be. We need to decide what it means to us. The visual discovery is where, again, heat maps would fall into this category as well. A heat map on a website, for example, where do people click? That's visual discovery, to say, well, how often do people click this button as opposed to this button? Somewhere in our website reports, there'll be a number. And that number will say, well, this thing got clicked X number of times and that thing got clicked X number of times. When we created a visual map of it, a heat map, and we overlay that over the web page and we see a brighter glow on that button than we have on the other button, then that's visually a signal to us that says, oh, they clicked that more. I wonder why. That's our discovery process. And then the everyday reporting is the stuff we're used to and have been doing for a very long time. So the few examples that I wanted to share and talk about, these are the things that we're all kind of familiar with. Now, there are a few links there, and there's one very good link that shows some examples, some very modern and very time-intensive examples of visualizations in a wide variety. I think the top 25 visualizations that someone has put together as a list. It's an insightful list of the way in which visualization can be used to portray ideas and to get understanding across. Because a visualization is generally not meant to convey just simple facts, unless it's the everyday reporting one. It's generally most powerful when it's used to convey a concept, to convey an insight, to convey a set of parameters. So we're all familiar with tables. Spreadsheets been around forever. We're familiar with charts that can plot individual data points within a range. We're familiar with graphs that create relationships between those data points. That's the sales graph, right? The one that's going up all the time. Tree maps, mind maps. We've all done mind maps at some point. We've also have fishbone diagrams out of UML, which is the Wakashashi or whatever. I forget his name now, the guy that invented it. The mind map idea, or the tree diagram, where you don't have a grid, you don't have an X and Y. Those data points aren't important. What's important is the cascading sub-relationships that come out of something. So again, that's the kind of visualization good at idea generation. Heat maps show relationships and intensity, but within an area. Network maps are, well, the org chart, the company org chart is an example of a network map. IT departments have 1,000 network maps, one for every different thing. So those of you who are familiar with IT networking will be very familiar with networking maps in a very explicit use of the word network, but that's not the only kind of network that exists. That's why I mentioned the org chart, because that's a network of people. You also then start to lead into unified modeling language, which is worth a look. And I should get that link put up there, because the UML 2.0, like there's 100 different UML. UML is where you get the modeling, visual modeling tools, like where you get the swim lane diagram, the flow chart, which is activity diagram. You get the use case diagram. You get the state machine diagram, communications diagram. These are diagrams that show relationships between things within certain rules. And you could have an entire short course just about UML. So we're not going to dig too deep into that. But UML, the great thing about UML is it's standardized. So when you do a flow chart, and we've all seen a flow chart, many of us have created flow charts, you have certain particular shaped boxes that mean certain things. A diamond is a decision point. It's a question. It's a, which way do I go now in the flow of activity? because that's what it's describing. It's showing activities. So UML, the benefit of its rules is that it helps what we talked about at the very beginning, pre-attentive processing. When someone is using UML and you say, oh, that's a flowchart, I'm going to be looking at activity. And I know where to start because you always start there. And I now know the rules of how to follow this because I know UML. Or I might look at a use case diagram and I think, well, okay, I know what actors are and I know what these lines mean. I can make sense of that. So I'm more easily able to have a shared understanding of what this means or what this contains, because that familiarity trigger is more deeply rooted in the rules that the illustration follows than it is in what I might be looking for in the meaning of the data. My earliest familiarity trigger from my subconscious will be the recognition of that type of visualization. So that's your starting point. Those unified modeling tools are generally segregated. They're simplistic. You get one tool that shows one kind of set of interactions and relationships and another tool that will show something else. So we've got plenty of time for questions. We have a few questions. Now is the time to think about some questions, if you've got any, because we're wrapping up the initial presentation part of it. Part of the point I want to talk about, and it will touch on a few other points as we go through the questions, but visualization, we already know, is a powerful tool for gaining insights. But no matter how powerful the tool is, no matter how good we become at creating visualizations, that is not enough. How we engage the tool, the visualization, with the stakeholders is more important. How well they have an aligned shared understanding, how well they understand what they're looking at, how easily they can get the correct meaning and insights, whether or not they can satisfy the query or the need from that visualization. That's what matters the most, and that's the harder portion. And that's the part that, in my experience, a lot of visualization creations are not taking into account. So I've seen plenty of very impressive looking visualizations that have had a lot of work put into them, that have been a very good example of the use of visualization as a tool, but are not necessarily creating the shared understanding that is needed in order to facilitate the best decision. And a final point as a warning on this, how we present the data, the visual data, can become the most significant step in the entire existence of that data. The collection of it, yes, that's important. The storage, the keeping it up to date, that's all important. But how we present it is often the most important step in the life cycle, in the usefulness of that information. Because in many situations, when big decisions get made in very important rooms with very important people in them, often the decision will be more significantly influenced by the graph that they all looked at than it would be influenced by what the stakeholders had to say at the time. Now, that's not an absolute rule. It's more of a red flag. It's more of a warning to say that it can have a distorted impact on what decisions get made, because it can drastically alter what people perceive to be true and real. So creating the visualizations, getting it right, is obviously relative to the importance of getting the decision right. And the amount of effort and time and detail that we put into creating visualizations should be proportionate to the importance of whatever decision it's feeding into, which is why when we go back to that framework, we start with the need and everything flows from that. To the point that you say, well, I have this need, I have this query. Now I'm looking at what data scale I have. Oh, I only have this type of data. It's not going to tell me that. Well, does that mean that maybe I just do a visualization with what I've got and hope that it tells the story? Or do we say, you know, this level of data isn't going to help us make the right decision. maybe we can get some more data, some better data. Maybe we could improve what we're putting in so we get the right visualization to make the right decision. Because in an agile environment, as we talked about last week, the quality of the decisions are more important than they are in a plan-based environment where you're putting in contingencies. In agile, the contingency is the quality of the decision. The contingency is the accuracy and relevance and treatment of the information that we're working with. And that treatment is the visualization. It's the last step in the process. So it can be one of the most important factors in whether or not an agile decision-making environment is successful or not. So those of you who talked last week about struggling with agile, or people or organizations that struggle with agile, ask yourself the question, how much of that could be contributed to because of the way in which we process our information and the way in which we present it, and the job it's doing or asked to do or able to do to help us make the in-the-moment agile decisions that we're expecting to make, because that's the agile structure that we have. That's the big question from what we've covered tonight. How are we going for questions, Guy? We seem to have a few.
Yeah, we've got plenty.
And we're on time too.
No, you've done very well. I'm sorry, everyone. You must have become used to 90-minute webinars and you're hoping for more. We've got an anonymous attendee, pretty relevant to this last slide, who thinks storytelling is more powerful than visual. You can, for example, you can draw something simple and have a powerful story that's more impactful than a nice chart with a poor story. Could the opposite be true? Is it important to have both? And sort of, well, no doubt there's it's an academic topic in its own right that has some body of evidence that suggests one way or the other.
It's actually the relevance of story and the way that's been explained in the question is a very good point, because it is another way of describing some of the things that I described in perhaps a more dry manner. But it's correct, I think, to say that story is the interpretation. And when you have story, you have a single interpretation that is expressed and shared. And humans respond to story in every way and everything. Story triggers the emotional response, whereas the visualization is only triggering the intellectual response. So with the story, we get meaning and we get engagement. And so it's always more compelling to have a story. And this is where the example that we gave you, right? So you go back, take your mind back to the poll, right? I could have just said that only giving you 4 and didn't give you 1 in the middle. And I could have just made that point, but I added story to it. I told you that Guy and I had had a conversation shortly before, and that was a little bit of story element that crept into that. And that made that whole point a different point. It was about something else. It was about us then at that stage. And many of you would have
Which must have shocked you all.
would have, well, you react differently to the question. So it is very powerful. And I believe it is true to say that a good story wrapped around a poor or weak visualization can be more compelling than a poor story around a good visualization. Now, here's the thing. If the story, the singular story that's told is good, then you're still okay. If it's not, if it's inaccurate or poor or political or distorted, then we're all in a little bit of trouble because we're going to have a distorted decision. But if you have a really good visualization, but you still have an unshared understanding where everyone has a subjective viewpoint, you've got a problem, because the decision will struggle because everyone's looking at this great visualization, but they're taking a different story away from it each time. But if you have a good visualization that's so good and so well constructed that it's laying out its own kind of story in the way it sequences the delivery of the information, then you can have a more unified story delivered by the visualization alone, which is less interpretive and more likely to be understood evenly by the participants. That's the goal. That's the gold-plated result that you're aiming for with the perfect visualization. When we don't get that, and let's face it, usually we don't, we have to make sure that the alignment of understanding is there. That's a really good question, but it does just tackle it from a different perspective.
Yeah, thanks, anonymous attendee. And I'll get you to cut questions now, actually, because we've got heaps that have come in, which is exciting. Alrighty, I'll work from the bottom, why not? Claire asks, can we have a few different examples in, what about using a few different examples in the one chart to explain different data? For example, a pie graph for one set of data, a bar graph for another set, statistical data for another. Is it too confusing or easy to differentiate the different types of data?
It can be, but go back to the question is, what's the goal with using different formats to represent the information? So if you're wanting to say, okay, this year was bigger than last year, bar graph is a great way to do that. And we're still looking at we're looking at sales figures. And then we're going to go pie chart because we want to show what different products that comprises, because we're going to show proportional out of 100%, which is what pie charts are good for. What you're focused on is the insight that is revealed. What I don't recommend is you reveal the same insight, but with a different tool. So you identify the insight needed, you identify the right tool for that, you put the right data in to do that, and then the next visualization needs to be looking for a different insight. Because if you're looking for the same insight, often you will be potentially causing confusion. Unless you're doing visual exploration, visual discovery, you don't know what the answer is, and you do need to look at the same data expressed a few different ways to spot what the insight is. You don't know what insight you're looking for. Then it could be useful because then you've got a much more exploratory mindset. But in general, it should be discrete, in my opinion. I'm guessing there's probably been some comments in chat about it that might have answered that as well. But that's my answer. That's what I would think.
And yeah. Also, different people could see different numbers of questions. Oh, very interesting. Perhaps you're only seeing the ones that have been answered or dismissed so far. Interesting. Okay. I've still got all of the open questions, which perhaps you won't be able to see.
There's a scroll bar on the question panel.
Yeah, I think we're seeing it differently to what those listening and watching along can see.
I have a scroll bar. There's a difference in perspective straight away.
Yeah.
Okay.
Alrighty. We'll keep Christina's question in there, but no more questions, please. We'll cut them off from now on. This is an interesting one from Henry. Can the same underlying data be depicted differently so as to influence the audience?
Yeah, I mean, people have been manipulating reports and expressing. I mean, visualization is just another way of how you express it. And you go back to the slide that I looked at before with the, size, color difference. You could have a bunch of things that are all kind of the same, but one of them is bigger and one of them is a different color, and they're going to look more important. And that's trickery. When it's not meaningful within the data, that's a kind of trickery. Now, it may not be trickery if you're saying, well, I want to draw your attention to these things because, and you have a reason, and that reason is part of a necessary understanding for the decision. But absolutely, it is plausible to use all these tricks, if you like, to distort the insight that is gained from the data. And that happens a lot. And I suspect that many of our audience would be dealing with that in some way, shape, or form, where if people get hold of a bunch of data, then they choose the visualization based on how they want to most favorably put forward what they want everyone to say, believe, and think and decide. So knowing how it all works is also valuable to deconstruct and look for that and find that as a consumer of visualization, you can say, well, I can see what you've done here. You've made this bigger font. That's not tricking me. I can tell that and sort of knowing how the brain works, knowing how the mental process and how the visual processes work is part of the tools that we all need to have to be able to sort through that sort of stuff when we need to.
Yeah, and hopefully we can assume that most of the time we're all trying to reach a shared understanding.
Yes, we do tend to have the altruistic view when we cover these kind of courses. But yeah, that's how you protect yourself from
it. Okay. Yep, so I've answered, hopefully, Jeffrey, your question as well. Can definitely be used or misused to lead a decision towards the desired outcome. Sarah asks, when presenting data, should you keep to the same visualization throughout? That's the question that we had from Claire, asked a different way. Keep to line graphs the whole way through? Should you throw a chart? Yep, beauty. So I've answered that one. Thanks,
usually,
Sarah.
yes, because I want to reiterate the point next to the thing, familiarity, avoiding the problem of cognitive load, where a person needs to look at an unfamiliar graph, then you're increasing the cognitive load, you're slowing down their processing of their understanding. Whereas if it's a familiar type of visualization, their processing is easier.
Yeah, yeah. Claire liked your answer to her version of the question too.
Excellent.
Most of the time, asks an honest attendee, we are asked to limit PowerPoint presentations to 1 or 2 slides. What data visualization is more effective to maximize the limited space?
The one this one. The very simple thing, when you have slide decks, always use animations. Incrementally make information available. Absolute golden rule. If you have nothing else that's important to you with slide decks, that should be number one. Everything else, yes, there's other things, but do that. Make the information appear piece by piece. And then at the end, you can get away with having a pretty complicated slide if you've incrementally added things. And then it doesn't quite matter as much which visualization structure you're using, as long as you are incrementally revealing it. But if you just go, bang, here's my massive chart, you hit that cognitive overload problem. And that happens with every slide. If I just put that straight up as an example, that's just too much information. And you're not going to listen and you're not going to hear what I'm saying for the next 30 to 60 seconds because you're reading everything. So in a 2 or 3 slide deck, incremental reveal is by far the most important element.
Yeah. It's a fair point. You're very good at it, and that one slide that you did reveal a whole lot at once was absolutely terrifying for me, trying to keep up with the chat as well.
Yeah, and you don't even notice it because we're so used to having it done to us. But it makes a difference. Cognitive load, processing the information.
Marielle says, but it's got to be a nice animation, not an annoying one. And Sarah agrees. No crazy slide transitions.
Nothing other than appear. That's all I ever use.
Disagree. It's got to be star wipe. You remember the old headings that you used to get with like the shading and God, they were fun. No sounds. Oh, come on, Tim. You're all such narcs.
They were fun for the first 20 minutes after they were put into PowerPoint. And then the next day they were old news and very annoying.
That's on my card. Old news and very annoying. Freddie asks, what is your thoughts about MS Power BI in general? And can you please tell us what Power BI is? And will you be writing a subject on this sort of stuff, which we've discussed before anyway, and including all of the Microsoft certifications on this sort of stuff in there? A fun fact for you, Brenton, in the chat, we were talking about burning down Microsoft. So there's that.
Why is that?
Oh, that's right.
I shouldn't ask. In the chat.
Yeah, well,
is this the point where I reveal that my wife works for Microsoft?
This is the reveal, of course.
My wife works for me. Yes, she does.
Yes. but Joe, I think it was, put in the MS shorthand and then use the MS $S. So I think that should give you some suggestion as to why.
Right. So Microsoft Power BI, powerful, not cheap. Nothing Microsoft does is cheap. That's their thing. That's their end of the equation. But yes, it is a powerful tool. But it's got some advantages. But they all have advantages and disadvantages, and they all. It's such a broad tool. The business data analytics is that the biggest problem is how much it can do. And it falls into the category of it's so broad in what it's capable of that your cost of acquisition is not just the cost of hooking it up and putting your data in it, but it's the cost of the data manipulation. You need to spend time, effort, resources, sometimes money, in making the data present in useful ways. It can do that, and any tool that data analytics tool that can present the data in a million different ways has that power and potential, but you need to have an understanding of what works for you. And this is where some organizations have been good at creating, and Google Analytics is a good example, where they have templates of, well, this is what we think you want to see. And most of the big data analytics business intelligence software packages try to do that, some more than others. But obviously, I don't want to go on YouTube saying too much strong things one way or the other about Microsoft in the end with this. But I do think it's a very powerful piece of software, but not for everyone. It's not meant for everyone.
Yeah, and really this is going to be, I think, the huge forum topic of the week. People's test cases. We've got so many questions about when to use which and why, and where do we find lists. Anyone that finds cool lists, chuck them in the forum. We've got some resources there already. I'd love to see people sort of saying why they like it and the ways in which it's been useful in their context, because that'll be, I think, the bit where it's useful.
I mean, I stayed away from recommending anything because I didn't want to go there.
Yeah, fair enough.
I'm hoping that people have comments, feedback that they want to share. It's in context. Talk about the tools that you're using. Talk about tools that are easy to use and work with and create stuff, and or not. And that's what these forums are for. And like, our attendees will have far more experience and knowledge about a great many things than what we could present. So I'm hoping that some of you will share that.
I know you didn't want to go too much into detail on UML, but we've got a question from Peter about just how does it work, and an anonymous attendee is asking whether they can just say UML equals flowchart diagram. This is targeted to any specific visualization on some team.
Flowchart is the most common, in my experience, the most common use of it. You'll find UML is covered a lot in the business analysis. Did we do a BA short course?
We did.
Did that have some UML in it? I don't know. I didn't write that one, so I'm not sure whether
that was before I knew what the hell you were talking about.
So UML is most common. It's a visual, two-dimensional, graphical illustration of things happening. So a flowchart is activity, and the activity sequence moves from box to box via the arrows on the box. A swim lane is an example of showing accountability. So the lanes would be, for example, roles, and an activity might, under certain circumstance, move from one person's in tray to the next person's in tray. And what do they do with it? And when does it go to the next person's in tray? So a swim lane diagram could be used to show the change of ownership of an activity as it goes through its steps. But the flowchart won't show that necessarily. The flowchart will show you the actions and the decisions that determine the next step in the process. So different UML tools are showing different pieces of what could be the same piece of functionality. You could have a communications diagram that will show you who communicates with whom in a particular scenario. So and there are a number of them, quite different. And if you go to the, as we'll put the link up, it's uml.org, I think, that you go to, and UML is a registered trademark of the UML organization. And UML 2.0 is the modern version, which is a few years old now, but it's got a whole bunch of things that a lot of you will recognize. And the most famous, the most classic is the flowchart of making a cup of tea, which is a very simple flowchart of, boil water. Is the water boiled? Yes, no.
That's great. I want to see that in the forum.
Yeah.
Uh,
So yeah, I don't know if I do that question justice, but it is a huge question.
Yeah.
And I look at it, UML, and then look at the images. Put it in Google and then look at the images, and you'll see tons of things that you'll recognize.
Getting a lot of people asking me to turn my camera on next week. You'll all rue the day, but I will do that for you. Yeah, goodness gracious me.
You're not in your garage anymore. That's a good thing.
Yeah, that's a plus. Arby asks about SPSS for visualization. I love SPSS. Have you played with it much, Brenton?
I've not. That's the IBM
one.
Yeah,
I used it for I did a uni subject, sort of quantitative research methods, and
good for statistics.
Yeah, like there was a world values study thing that we got access to, and it basically had hundreds of thousands of people asked, dozens or even scores of questions, and it was and you're able to sort of choose your data points and really and look at really interesting relationships, and then muck around with ways of visualizing these relationships, and sort of trying to get it to apply to a theory. Bloody great. If anyone else has any other use cases for it, I'd be super interested in hearing it. But I think it's fantastic.
A statistical analysis is not going to be useful for every question, but it's actually useful for a surprising number of questions when you can get statistics to do whatever you need them to do.
Yeah, indeed.
So it's surprising what you can do. And a lot of things with it that we don't call it statistics, it's just a few numbers in a spreadsheet, but it's in mathematical terms, what we're doing is a statistical analysis of some kind. Every time we look at the average of something, we're any kind of planning around a bunch of numbers is usually going to be some kind of statistical thing. So it has a definite role to play. And, the IBM is aiming certainly at larger organizations who rely on the quality of those decisions. And so they need the statistical analysis to be able to make good ones. They need to see what other people would miss. The stuff you'll never see if you just look at a spreadsheet.
Fun fact, the finding I probably abused data for was the extent to which people identify as post-materialist as opposed to materialist corresponds more strongly to a left-right political bias than their general idea about how useful unions are these days. So there you go.
And some people are thinking, man, you needed statistics to tell you that? We all knew that.
Yeah, but now we can visualize it, can't we?
Yeah,
and that might affect people's decision making.
And you can prove it irrefutably. So now you can act upon it.
And just scrape through on the subject. Can you give, please, Brenton, some examples of when we should use R and what cases should use Python? And could you please also say what R and Python are?
Programming languages.
R.
So I'm not a coder. That's not a question I feel safe to answer. SPSS will work with both, I can tell you that. But you're talking about different ways of creating logic. And Python, extremely popular, useful method of creating logic. I think when it comes down to those sorts of choices, it's a lot more to do with the skill, experience, and understanding of the practitioners who are working with it than necessarily the tool itself. So I would think the question maybe going about it a different way. I mean, I've chosen tools based on the people that I have and what they know and are familiar with and the tool that they can work with. And often that's been the right way to get the best result I can get. Because if I go for a tool that on paper says it'll do something more different or better, but I've got to go through the learning curve and we've got to get to the point of leveraging that possibility, that's often a tougher journey. So, I mean, long time ago, I created a billing system, ran it out of Excel because we couldn't, at that stage, we couldn't yet choose and find the right billing system that would do everything we needed. And so we ran it out of Excel for 6 months until we did that. Excel's not the tool you use to run a billing engine, but it could be made to do that because we had the expertise to do it. And the people that ultimately took on our billing looked at it like their eyes went wide. They think, wow, you did what with that? But I don't know enough about the coding and the programming languages to be able to responsibly comment on which one's better for this or that. I haven't done coding. Well, I haven't done coding since a very, very long time ago. Not an expert there. I'm assuming since I've been kind of waffling about this, someone else may have answered the question in chat.
Yeah.
And given their view. Has that happened?
Well, Richard,
someone help me out.
Sent some chat to just us panelists. Use Python for everything. Use Rust for everything else. Bit of fun there. Joe says EA is a good tool if it's still around, and Amanda says yes, it is still around. So thanks for that, game. But yeah, again, forums, use cases. Tell us what you think. Tell each other what you think. More importantly, yeah, help each other out. It's lovely. So Shadri, can you sell it just a little bit more, Brenton? Are you familiar with any successful examples of people assisting with strategic decision making using visualization? There was some cool stuff in the chat before about London plague visualizations. I'd have to scroll up to the top, and there's far too many chat messages to see them all. But famous visualizations that have been
the cholera outbreak in London, where they isolated that it was coming from the groundwater, from the wells. And they did, that was essentially a heat map before they even knew what a heat map was.
Yeah, amazing, isn't it?
Yeah, they were correlating cases within certain localities, and they got to say that, well, what's in common with all this? What's geographically common in those areas? And they had this, the reason, when they finally nailed that example, it's because they had some outliers. And when they had an insight that could account for the outliers, then they knew they had their answer, because they had one location, one well that was tested, and they knew it had cholera in it, and they closed it. And a lot of people in the area had the problem, but they had one little old lady who lived quite a distance away who also was affected by it, and they didn't know why. And eventually they found out that she used to live in that district, and she preferred the flavor of the water from that pump. And she had her son who worked nearby, who was bringing back bottles of it to her in the outer suburbs. So when they start to get those sort of information put together, they started to realize that that kind of mapping of data was precisely the answer that they needed. And they were right. And that's when they had a solution then. There's another really famous one that I really like, which is the graph of the line graph showing Napoleon. Was it 1812, 1813? Showing the distance traveled, the losses in the army, and the temperature, and factors like this. And it's just a bunch of lines on a graph. But you look at that and you can see exactly what cost him the war just by looking at a line graph.
Hubris.
You can see that as they traveled, the army got less, and the temperature went up, and then there's the question of, well, what's the issue? And you then start looking at repercussions. You'll think about buttons, and the fact that a lot of them had lost the buttons on their coat. They couldn't close their coat, so they suffered hypothermia more readily. But that's not when you start to say, okay, we can see that it's cold that did this. Why did cold have a disproportionate effect? And then you start to do an audit of the condition of the clothing, and then you can say, well, okay, it's to do with the condition of the clothing, to do with the sewing on of buttons and the lack of buttons, etc. And you start to reveal, I mean, if they had that sort of visibility to that sort of data, if Napoleon had that at the time, things might have been different for him, yeah?
He wasn't doing the weekly, he was doing the weekly reporting. He just wasn't doing the exploratory, what is it,
No.
empirical, exploratory. What was that one? That was, where's
Visual
your
discovery.
matrix? Where's your matrix?
Where is my matrix? There it is.
There we go. Visual discovery. There we go. Lot of,
So
had some
that's a
good
couple
chat
of
about that matrix. People like it.
Google that one, the Napoleon casualties in 1912, 1812, 1813. Maybe I'll find it or put up.
Yeah. There was some good chat just before. Thanks, Hamilton, for the cholera
Link?
example.
Oh, someone's put the Napoleon graph up there. Michael has.
Fantastic.
Excellent. Thank you.
That's great. Rightio.
That's Tableau, yeah. So Tableau is one of the tools. Tableau is one of the companies, I believe, that does stuff. So I didn't want to use their links.
Rightio. Let's go for Carmen. Are demographics such as age and experience considered in data visualization? No doubt sometimes. In my experience, age and experience makes a huge difference in the interpretation of what they see. How do you play with demographics in getting understanding?
So I didn't bring it into the discussion tonight directly, but indirectly, you can find a link. I would link it via familiarity. So if you take the age and demographics component away and say, well, what is it about age and demographics that is fundamentally causing differences in the interpretation, use, familiarity, comfort, and shared understanding of visualizations? And it's a lot to do with their familiarity. So you have people that are older and have had, 20, 30, 40-year careers looking at spreadsheets and not looking at other cool graphs and not being as familiar with them, not being as trusting of them. And I'm stereotyping now because I'm assuming that it's the older demographics that are less comfortable with the more modern, but that's the assumption I'm making. But if that is the assumption that we're working with, then it's not because of their age. That's not the reason. The reason is their familiarity. And we already have talked about and established what familiarity does. It increases the processing time. Lack of familiarity increases the processing time. So more familiarity decreases it. And the creation of these tools, a lot of people think about these tools and when they try to wrap their head around it, they often think about it, well, if I figure this out, I'm gonna be asked to do them, right? I'm gonna be asked to create them. So for a lot of people, that's a deterrent. That's a reason to not. So I would just put it in that category. Just think of it from a familiarity point of view. And then you've got something to work on, because if you just look at it as age and demographics, you can't change a person's age, but you can change their familiarity with visualization. So that gives you a more proactive approach to it, I think.
They'll probably just prefer the cholera water anyway. Oh, who said that? That was tasty cholera from PJ in the chat. Thank you. What is the delineation between IT and information management? That's a question from the very start. Where does the data visualization sit or best fit?
So next week, topic 4 is going to be a more complete answer to that question, because we're going to talk about dashboards. So we're going to talk about, as you probably predict, the psychology of dashboards and then the functionality of dashboards. And that's an area where IT very much has a deeper obligation. What we've talked about today is very much the influencer, the user, the person who is wanting to influence a decision or to create and present data that is meant to influence a decision. So that's a practitioner of decision making, or a consultant contributor to decision making, who's got tools and systems and data. Now, quite likely, the IT department has a responsibility for making sure that you have good visualization tools available. You've got a license, you can access it, you have logins, you have a place to store it. And that side of it is going to be the IT perspective when it comes to that sort of thing. So definitely any IT department should have, as part of its remit, making sure that amongst all the other software tools we have available, we have visualization tools. Because, there was a day back when I used to do things that you had to write your own Perl script. If you wanted a report, you either had to convince someone in the IT department to help you write a Perl script to get that report, or you learned how to do your own. Those days are so far and gone, but the IT department still has that responsibility for the tool, for its support, its management, its installation, its purchase, its availability. And so there's that clear link. But next week, it'll get a little bit more complicated.
Good signposting. Let's finish. I just got rid of a couple of questions, which I think we had already answered through the answers to other questions. But final one for the night from Rahul. Why do you think in-depth research is important along with strong visualization points? Sort of going back to that first question. I guess it's a good story.
So I'm going to make an assumption with the context of the word research, because I'm going to assume that it's research on the data that's being used in the visualization rather than research about visualization, because a lot of what we talked about tonight is research about visualization in general. So, but if we assume that research here, we're talking about research of the data that gets used, I think that it's validation. So the more in-depth research you do on the data that you have, the more valid your insights and conclusions will be. Because remember, at the end of the day, it's got to feed into a decision. So the more clarity you can bring to the sequence of logic that says, well, from this data, this story is told, this insight is gained, and this decision should be influenced. The stronger that is, the more consensus that you'll have and the more success you'll have with the decision, because in an agile environment, that's an important thing. So, but there's a contra there, because in-depth research isn't inherently agile. And that's where you get things like BI software, and you get systems that are constantly massaging and presenting your data. The data just falls into the bucket and it's always available, so that the in-depth research is much quicker to do. The investment in those tools, the investment in having those systems is increasingly paying dividends for companies. And this is why there's an entire industry that's growing exponentially to cater for those demands and requirements. Because, you know, it wasn't too long ago that big data was a bit of a buzzword. It was a bit of a cool idea. Now it's a commercial necessity. But the big data, that's kind of always there. It's always been there. What's new is how we're able to use it. And what's now required is the mature, effective tool and the skilled, experienced, and trained people that work with it that help you get the best out of it. So in-depth research is really important if you're talking about it on the data. If you take a couple of other contexts there, in-depth research on the right tool and the in-depth research on how to go about it, all has those corollary effects of ultimately getting you a better decision. But that's what it all comes down to.
Thank you, everyone, for sending in those questions. About 30 of them tonight, so good job. Thank you, Brendan. Very excited about next week. And we'll have a chat about the exam then as well, everyone. So we'll have a lot of fun writing those questions, no doubt. Pretty. All right. Well, thanks everyone for hanging around. Still about 230 of you around. So good job for hanging around. And thank you, Hannah, very much as ever for sticking with us. I'll leave it off to you, Brendan, to sign off and keep chatting away in that forum. Give us your use cases and your experiences and contexts. Thanks, everyone.
Thank you, Guy. And thank you again, Hannah, for your tireless work behind the scenes. And thank you, everyone, for your questions. Thank you for your comments in the chat and for sharing your ideas with each other. And thank you in advance for those of you who will put some ideas up in the forum. This is a great week to be sharing these ideas because there's a lot of subjectivity. And I hope many of you do, and I appreciate it, and I thank you for doing so. And I look forward to seeing you all again next week for our fourth and final topic. Until then, that's all from me for now. Thank you and good night.